So here we're going to expand expressions using those properties we just talked through. So what this will do is this can be a way of simplifying the expression or just kind of re-expressing the expression. So we'll end up with these equivalent expressions, but sometimes one will be easier to evaluate than the other. So what we're going to be doing in terms of expanding, that's where we'll have one logarithm and then we'll stretch it out into two separate logarithms. So probably mostly focusing on those rules of the sums and differences with that multiplication and division, but we'll also talk about that exponent rule and some identity rules in there as well. What I would recommend doing, since it's a little difficult for me to switch between pages on this, having those rules out so that you can see them and we can make sure we're applying them correctly. Alright, this first example here. So this is one we've actually looked at already when we talked about the domain and range of graphing. So what we ended up with for the restriction on our domain was that x had to be more than 3, and that came through thinking about the graph of this rational function, this 1 over x minus 3. So we did this whole thing of thinking about the transformed graph and where it was landing, and then we ended up with this. What I want to show you with this is that when we actually expand this and simplify, we end up with something that would be easier for finding that domain. So keeping in mind that whatever goes into a logarithm has to be larger than 0. So what we can use here is the fact that we have division inside the logarithm. So if we have division inside the logarithm, then what we can do is change this. So we can re-express this using subtraction outside the logarithm. So what we're going to do is take this single logarithm here and stretch it out into two logarithms. So we're going to have logarithm, and we're starting with base 10, so we're going to stay base 10 through all of this. So I can stretch this with logarithm minus logarithm. Because it's division, that'll relate with subtraction. Now, in our first value here, we use the numerator, so we'll have logarithm of 1. For our second expression here, we use the denominator, x minus 3. And now I simplify. So logarithm base 10 of 1, we have our identity property that said whenever we have a value of 1 inside, that means we need to have an exponent of 0. So this is the same thing as 0 minus that logarithm of x minus 3, which that 0 is just kind of extra there, so we can get rid of that with negative log of x minus 3. Now, what I was saying before about seeing this x more than 3 limitation on our domain, now it's a bit more clear here, because all we would do is say, okay, whatever is inside the logarithm has to be more than 0, add 3 to both sides, and we can see that domain without having to graph a rational function with a transformation, thinking about how that translated. So the idea is that where we started here is the exact same expression as where we ended up here. So we expanded it. However, part of the expansion has a value of 0, so we actually ended up with a single logarithmic expression there. Now we could have done this solution another way, and as we go through these, I'll try to include these multiple ways of getting to the same answer, because sometimes it'll make you look out for different ways of doing it, and there might be a method you prefer. But how we could have done this is where we started with logarithm of 1 over x minus 3, what I could have done is express the inside of that logarithm a different way. What I could have done is written that as the logarithm of, and then what I have here is this expression x minus 3 in the denominator with a numerator of 1. So how I could have written that is that expression x minus 3 raised to a power of negative 1. So that exponent of negative 1 would just take everything in the parentheses there and move it to the denominator. So those two expressions are exactly the same. Then what I could use is the rule that says if you have an exponent inside of your logarithm, put it out front. So we would have a -1 times logarithm of x minus 3. It's a little less work there, but we get to that same answer. It just takes some re-expressing of the inside of the logarithm first to get there. So either way would be fine to getting to that simplified form. Now, another key piece with these is realizing when you're done simplifying, when you can't do anything more. So when we get here and we see that subtraction inside, students might be like, oh yeah, so now we do division. But remember, it's the subtraction outside the logarithm. Then we can do something with it. If we have subtraction inside the logarithm, then it's done. This is our last step because there's nothing we can do with that. Look for like terms that you can combine. We'll talk about looking for factoring that we can do, but here there's nothing more that we can do with x minus 3. All right, this next example here, so what we have inside our logarithm is multiplication. We have this value of x times this radical expression here. So we have multiplication inside, and what that can work together with is the idea of addition outside. So what I'm going to do is split up the logarithm, so we're using a natural log. So we'll have natural log plus natural log. So that's how we can split up with multiplication. And then what we do is we use the separate factors. So we have a factor of x, and we have a factor of that radical expression. So we have x, and then this square root of 1 plus x squared. Now in terms of simplifying further, natural log of x, there's nothing more that we can do with that. That's done. Nothing to evaluate. Natural log of this radical function, there is something we can do. We can simplify this radical. So what we're going to do is re-express that radical as a rational exponent. So we're going to have natural log of that 1 plus x squared in parentheses raised to a power of 1/2. Now what we'll have from that is this exponent inside the logarithm, and that can move out front. Notice that that exponent is covering everything inside the logarithm. That's an important point to note, and it's going to be these little nuances of these rules that we need to follow. But why I want to emphasize that is because if I then had like a +2 on the outside or something like that, then I wouldn't be able to use this rule. It's the fact that that exponent is covering everything inside. So from there, I'm going to have natural log of x plus, and then that 1/2 out front, natural log of 1 plus x squared. All right, now to go through my thinking of, are we done simplifying? Like we said before, natural log of x, there's nothing more to simplify there. Like if I tried to simplify, it would be like thinking, okay, e to what power would give us x? Well, we have no idea because we don't know what x is. So that's where that's all done. The 1/2 times the natural log, nothing to really do there. That just has to stay out front. And then in terms of what's inside the natural log, so addition inside, there's nothing we can do. Addition outside, we actually want that right now because we were told to expand. So I don't want to then combine these using the multiplication rule because that wasn't part of it. They're telling us to expand it, so we want to make this expression longer. The only other thing I would look for is factoring in here. I would look to see if I could factor that, because if we had factors, then we could use this rule that we started with again, because we'd have multiplication, then we could stretch that out to addition, so we're just stretching out our expression. However, it would work if this was subtraction between them, because then we would have difference of squares. Since it's addition, there's nothing we can do. So with that, this is all done simplifying. Okay, our last example here. So logarithm base 5, so I'll just keep that in mind as we're writing our logarithm as we go through our work. And we have division. So we have division inside, which means, like our first example, we can switch this to subtraction outside. So I'm going to separate this into log base 5 minus log base 5. For our first value, I'm going to use the numerator. So that's that cube root of x squared plus 1. And then log base 5, x squared minus 1. Now I'm going to simplify. So looking at our first term here, I have a root, so I'm going to express that as a rational exponent. So what that would look like is that whole x squared plus 1 raised to a power of 1/3. So now what I could do is take that exponent and move it out front, so I'll be part of my next step, minus, and now what I can see here is I have that difference of squares like I was talking about in the previous example. I can factor what's inside that logarithm. So I'm going to go log base 5 of, and then factoring with my difference of squares, we would have x plus 1 times x minus 1. And now what I have over here is this multiplication inside that I can expand to addition outside. So that's going to be part of our next step. So my first term here is going to simplify to 1/3 out front log base 5 of, sorry about all the noisy trucks. I don't know how much the microphone's picking it up, but it's snow day and the snow plows are being very loud and constant. So sorry about that. Okay. So 1/3 out front, log base 5 of, and then everything that was under that exponent. And then I'm just going to make note of, if I could factor that, I would, but x squared plus 1 doesn't factor. So this means our first term is all done. That's it. Now, over here, this is going to be one of those little nuances of how we're expanding our logarithmic expressions. Because what I'm going to do is when I expand this, it's that where I have a single term here, I'm expanding it into 2 terms. What I need to know is that I have subtraction here. When I make this replacement, I need to use parentheses. This is incredibly important because we're subtracting this entire expression here. Well, then what we should have is a subtraction of this entire expression. But when we make this expression, we're going to have addition in there. And we need to use parentheses here so that this subtraction of the entire expression translates correctly. Because what we're going to end up needing to do is distribute that subtraction inside. So if you have operations occurring out in front of your expression and you make an expansion, you have to use these parentheses to have it translate correctly. So here we had multiplication inside, so what we can do is separate to addition of 2 logarithms. So we're going to have log base 5 of x plus 1 plus log base 5 of x minus 1. So we need those parentheses to group this entire expression here, because this entire expression is replacing our single expression there. Now what we're going to do is, like I was saying, we want to distribute the negative inside. So what this will look like is we'll have our 1/3 log base 5 of x squared plus 1 minus log base 5 of x plus 1. And then minus log base 5 of x minus 1. And that would be our fully expanded form. So what I do is go through and there's nothing I can do with those expressions that are inside the logarithm. There's no more simplifying to do. That would be where we end. So this is our expanded form of this one logarithm. It got expanded into 3 logarithms. But in this expanded form, the overall expressions that are inside the logarithm are much simpler to work with. So in terms of evaluating, it would be a bit easier.